Okay, welcome to part 20. I think we're about halfway in through the series. So today we're gonna be learning about magnitude and maybe region 3 as well. So I have these two parts here. They're both the same size, aligned to the grid. Actually, I think this one is floating. Oh, never mind, it's not. Okay, so yeah, we have two parts. Part 1, part 2. Both are size 1,1,1. And they're aligned to the grid. So magnet is mostly used to check distance. There's some more uses to it, but mainly for that. Okay, so let's make a script in here. I'll just rename it to like check distance. Okay, so we're gonna print out the distance every 2.5 seconds. So while task.wait 0.25, it's the same as 0.25 do now. So I'll just type it out and explain. So local distance equals parentheses actually let me make a variable for the two parts real quick. Local part 1 equals script.parent.part1 and local part 2 equals script.parent.part2 part 2. Okay, now local distance equals p1 dot position minus p2 dot position dot magnitude. So we have variables for all parts for quick access, and we made a variable distance and assigned it to part 1 position minus part 2 position and then dot magnitude. So this is how we check the distance. So magnitude just converts it to studs pretty much. So magnitude just have we measure in studs, and we have to first do the math before we magnitude it or convert it to studs. So parentheses, and now if we just print it out, so print distance, it's gonna print the distance 9 studs. So if you go here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm not sure why it isn't 10, but it's pretty much accurate. It should start from the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But yeah, as you can see, if you move it, it's gonna change. But it's gonna show us a double value. By that, it's just a float value, so a decimal number with lots of numbers behind it. But as you can see, it works. Just move it all the way over there. It's gonna be 800, 330, and if we put it inside it, it's gonna be 0.9. So we can actually make it more accurate. I think it's gonna be more accurate by rounding it up. So let me show you real quick. Math.round this. Okay, so pretty much what this does is rounds the number. So if the number is 0.5, it turns to 1. I think it's 1. Yeah, it should be 1. If it's less than 0.5, or the decimal number is less than 0.5, so 0.4, it's gonna equal to 0. And if it's higher than 5, it's gonna equal to 1. So that's rounding. There's also math.floor, which always lowers it. So if it's 0.6, it's gonna be 0. In math.ceiling, is it math.ceiling? Math.seal. Okay, I think it's that. Math.raise. Okay, I don't know. I'm pretty sure it's math.seal, which turns 0.4 into 1 no matter what. Or if it's lower than 5 decimal, it turns to 1. But rounding, it just pretty much does this. Okay, so if we do it now, usually I will floor it. I don't know why, but usually people floor it. I think it's for some reason more accurate. But not that means, but just they usually just floor it. So no more decimals. So it's 1 distance even though there's not one start distance here though. 1, 2. I think if I just add one, I mean, it's not gonna be accurate anymore, but it's still just gonna make a more visually accurate version of it. I wouldn't recommend doing this. So 1, 2, 3. If this block is like too wide, it's gonna be in the middle. It's never gonna, the middle is never gonna be the edge. So if I make it like, let me see, size 2, 2. So if you just move it, it's gonna be 5, even though it looks like it's gonna be 4, but the actual middle is here. So the middle is here. So it's 1, 2, 3, 4, 5. Okay, it's a little bit confusing, but you get the point. This is how we check distance with magnitude. It converts it to studs. Okay, so now we're gonna be talking about region trees. So region trees is pretty much just, okay, I have this ignore part here, that's for later. Let me just duplicate it. So region tree pretty much gets 2 points. So that's this position and this part's position, and it just fills them in. So yeah, it just thinks, so that just, I mean, if you imagine it correctly, it just fills it in. So if I will do a region tree on here, it will, and the result will be something like this. So yeah, a region tree just fills from one part to another part, and then you can use it to detect what's inside this part. And there's a new function, so you can detect it anyways. But let me make a region tree real quick. Gotta delete one of these parts, this one here. Okay, so local reg equals region3 dot new. Okay, so I'm making a variable named reg, and it's gonna be equal to a new region. To create a region, you need 2 vector3 values. Vector3 dot new 5, 0, 5. So the first is gonna be a vector of 5 on the x, 0 on the y, and 5 on the z. Make another one. Dot new 20, 20, 20. So the first vector tree I created, that's gonna be the first point, and then the second point is gonna be this one. The first one always has to be smaller than the other one. So this will create our region. Now let's make a part and let's make it the size of that region. Local new p equals instance dot new part, and the parent is gonna be workspace. So you can just type workspace, you don't have to do game.workspace, but it's just good practice to do so. And new p dot anchored equals true, so it's gonna be anchored. New p dot, yeah, that's gonna be about it. Actually, no, wait, what am I doing? New p dot transparency equals 0.5, and new p dot can collide equals false. So actually we have to set the size as well. New p dot size equals reach dot size, so the region size, and now it should spawn somewhere in the world. Here it is. We have our region. It goes underground as well. As you can see, this is our region. 20 stats high, 20 stats. So this bottom left corner, I'm assuming it could be any of the bottom corners. It's at the position of 5, 0, 5. Okay, so one of these corners is at 5.5, 0, 5 on a vector3 value, and the one of the top corners is 20 at position of 20, 20, 20. Well, obviously it's not anymore because I lifted it up, but that's the premise of it. It created a it had 2 positions, one over here and one over here, I'm assuming, and it filled it in. Again, it could be any of these corners, I'm not sure which. But yeah, it just created a region. We can actually lift it up, so if I do new p dot position dot y. Can I just change the value? Plus equals, I'll do like 10. Okay, I can. So plus equal just adds 10, so I don't have to do new p dot position dot y plus, equals new p dot position dot y plus 10. This is just a shortcut to avoid that. Yeah, okay, so you have to make a new position. Okay, new position equals vector3 dot new p dot position dot x, new p dot position dot y plus 10, and new p dot position dot z. So this is gonna lift it up the ground 10 stats high. I think I have to do a little bit more. Oh, that's perfect. Actually, I'll do 9, so I can just demonstrate something. So now what if we want to detect something, or what if we want to detect everything inside that region? Well, let me show you how to do that. So while the task dot wait 0.25, it's gonna check every quarter of a second what's inside there. Local collisions, I'm gonna name my variable collisions, equals workspace. You can do game.workspace colon find, get part in part. Okay, so it's gonna get parts in parts, get parts in part. You can use this in any part, but usually there was a function called Region3 dot get parts in Region3 or something like that, but it's deprecated, so you can't use it anymore. I did the same mistake on the raycast video. It used a deprecated function, so I'm sorry about that. I'll definitely have to comment the new one there, but anyways, the first parameter is the part, so new p, and the second one we're gonna talk about in a couple of seconds. Now we're gonna loop through, because this here returns an array or a table. So array is another name for tables. Okay, so it's gonna return a table. So for I, comma part, so you can name I or V anything. I'm gonna name it V in pairs. Now the table collisions do print v dot name. Okay, so this is gonna just print anything that touches it, like the base plate right now, and all my body parts, hair and stuff like that. So yeah, as you can see, it prints anything it wants. So let's make it ignore the base plate. So for that, we're gonna use overlap params. So you can obviously, it's like tween information. You can put it right in here, or you can do it more nice looking way and just make a variable for it. So local filter equals overlap params dot new. Okay, so it makes a new overlap param and assigns it to this variable named filter. And now we have a couple of things like filter dot max parts. So it will only have max parts. So if you have like 101 parts in there, it won't put the 101th part in the table. Let's set it to like 1 million. Sure, why not? Actually, let's do it like, sure, yeah, 5 parts, sure. And filter dot filter type equals filter type, enum dot filter array has filter type dot. Okay, so we're setting a filter type, and we just need blacklist and whitelist. So we're going to raycast filter type. There's nothing to do with raycast, but it works the same. So ignore this and just look at the blacklist or whitelist. We're gonna do blacklist. And now we can set what we want to filter. Dot filter descendants instances equals, and this takes in a table, and you put the path to your parts that you want to ignore. So workspace dot baseplate and workspace dot ignore. It's gonna ignore these two parts. Is there anything else we can do? I haven't looked at the other things. Respect can collide. So if this is true and something has can collide off, then it won't print that. But if it's false, then it doesn't matter if it's can collide is off. It's still gonna detect it. Other things, I'm not too sure what they are. You can mess around them with if you want. And now, oops, it's not gonna work. Now you wanna take your filter variable and plop it in as the second parameter. So if I go in, it's gonna ignore baseplate. It's gonna ignore this part here. As you can see, it doesn't print it. But if I go in it, it's gonna print all of my body parts. Left lower arm, left upper arm. Yeah, all of my... Does it? Oh, it doesn't print my accessories. Okay, well, that's pretty much everything about region 3s. There's a couple of things maybe that aren't that necessary to learn. But yeah, you can experiment on from here with region 3s. But yeah, that's everything for this episode. I'll see you in part 21.